My name is Harish, and today we will be analyzing a simple data set using SAS Enterprise Data Miner as a tool that creates predictive and descriptive models. Let's go ahead and get started. In the interest of time, I have already created my diagram and have completed this with three models and a comparison towards the end. Let's go ahead and start with the file import. I have imported a file called wages from 1970 from my local drive in here. This particular file was likely downloaded from uci.com, but it was already handed out to us in a different course. This is a very interesting data set to me when I was working on it earlier, so I brought this in to see how this visual model will give us some information about this. Um, this particular data set that we'll use today is a bunch of wages that was collected back in 1970. We will predict if the person belonged to a labor union or not, given the different variables in here. Although labor unions were predominant in early 19th century, the labor laws themselves had relaxed a little bit towards the 1970, and the unions themselves started diminishing. So it'll be very interesting to see if we can determine how the wages really mattered against being part of the labor union or not. Let's look at the Stats Explorer tab here. I want to just look at some of the statistic measures just to see if we can make anything out of this data in this data set. So these are how my union variable is worth against each of the variables, other variables in the data set. In particular, I'm actually interested in my union against the wage. So let's look at this occupation, race, sector, sex, and then the south and the age, wage. So I wanted to look at in here. The first one is actually the second column in here. Second row is the non-union, and the third row is the union. If we look at here, it is positively skewed. 1.95 is actually heavily skewed, and that's pretty common because as a part of the if you were part of the union, you stood a better chance of earning a higher wage. And although you earned wage nevertheless, but then as if you were not part of a union, then your wages most likely was less or more. So we can see a positively skewed data set in here. So let's start with the neural network. Let's see how this neural network did on this particular data set. One of the things I wanted to point it out is that the optimization I used here is called the backpropagation, which was taught in the class. And in that, the main thing to note is the learning rate and the momentum, which has to be very low to get a higher accuracy. That was the concept one that we learned. Let's go ahead and look at the results in here, how the neural network model did. Let's look at the results on that a little bit. Now this is the average squared error that is showing, and it is not showing a convergence. Let's look at that. Before that, let me show you we have a good information on the we have the sum of the squared errors. So the errors is at 35, 46, and 49% on each of the different subsections of the data set. We also have the misclassification rate, which was 12% on training, 19 and 20 on the validation and test. So if you look at the output itself from the neural network, there are a lot of weightages and how many iterations it's going through. It went through 50. It shows various other information in here. The one thing that I'm really interested to see, as you see here, the back propagation logic says that it needs more than 50 iteration. So it was not able to find the better optimization. We can see that in here that it did not find a convergence point. Okay, let's go ahead and while we're on the neural network, I also used something called the high performance neural network model that I have in here in SAS. This one is very interesting. If you look at the results, you can see the reason I picked this model over the vanilla neural network model. If you look at in here, in the iteration plot, you can see here at the 13th iteration, it was actually able to find a convergence on this particular model. So I'm assuming that this is going to be the model that's going to be picked or used because of the fact that we were able to converge on some point. If you see here that on the training data set, it was 12% and 13 and slightly higher on validation and test, which is pretty normal on the average squared error. Let's look at what we have on the misclassification. So we have a pretty even misclassification rate. So it is at 18% on the 40% of the data set for training, and then 18 and 17 about the same percentage for the 30% for the other two subsets of the data. Okay, let's now that we've looked at the neural network, let's look at what a different type of algorithm called naive Bayes algorithm did to this. Let's look at the results in here. In the class, we learned that the naive Bayes algorithm treats one feature completely independent of any other feature in the data set. So that is just another type of algorithm that is used in a predictive model. If we looked at in here, let's look at what it did to my average squared error. While it's about 13%, as we remember from the HP neural, we had a 12%, and 13 and 13, we have 13, 19, and 21 in here. So another concept we have learned that is to look at the average squared error also as a part of the deciding criteria in addition to the to either the misclassification rate or the confusion matrix itself. Also, in one of the concepts that were taught is to compare against different models, not just stick to one model. So we have used three different types of algorithms and models in here to see which one fits the most. If you look at the comparison now, let's look at the comparison results. So if you see in here, the minor tool picked the HP neural network algorithm as the best fit for this particular data set, and it was based on the validation data set misclassification rate, which was at 18% and slightly higher on neural network and very high on the naive Bayes algorithm. There are more information that we can load. It shows the information for each of the subset of the data that it used. Okay, that brings us to the end of this session. Thank you very much for